Hey there, in this video we're going to work with multiplying matrices. And so one of the questions is what products can we find? So what dimensions work? And so one of the definitions for multiplying matrices is that if A is a matrix that has dimension n by n matrix and B is Bij is a n by k matrix, then when you multiply them, A times B is going to be a new matrix, so we'll call it Cij. And the dimension of this matrix is mk. So it will be an m by k matrix. So when you do A times B, you're essentially doing the Aij, which is an m by n matrix, times the Bi sub ij, which is a n by k matrix. So you want the number of columns in the A matrix to match the number of rows in the B matrix. And then your final product is a matrix that has the dimensions, the first one, the number of rows of A, and the number of columns of B. And so let's try an example. So I have these matrices here. And let me just get rid of this so it doesn't look like it's the same thing. So my example is if I have these three matrices, which ones can we find products of? And so this one, the dimension, let's see, it has 3 rows and 2 columns, so this is a 3 by 2. B is a 2 by 2 matrix. And what about C? C is a 3 by 3 matrix. So I can certainly do A times B because the number of columns of A match the number of rows of B. And then I can't really do B times C because the number of columns of B don't match the number of rows of C. So I can't do that. And let's see, I could only, really all I could do is A times B. But we could also do C times A because the number of columns of C match the number of rows of A. So we could do C times A. Right, so this is a 3 by 2 is A. You're multiplying it by a 2 by 2. So the dimension, the resulting dimension, will be a 3 by 2 matrix. Right? You take the number of rows of A by the number of columns of the second matrix. And so we'll see what happens when we do C times A. So how do you multiply two matrices? So the multiplication process, and I'm going to do it sort of in general, and then we're going to go through our actual matrices. So if I have a matrix and I have the ith row, and it has some entries, we don't know what they are, so I'm just going to do that. And I'm multiplying it by another matrix, and I have the j column, the jth column. So something like that. Then when I multiply these, so I will do the first row, entry in that row times the column plus, and then we go down the line. And you add all of these. And that will give you the entry, the Cij entry. So now it doesn't give you a whole column or a whole row, it just gives you an entry. So let's try to work it out. So for our example, A times B is the matrix A, so I'm going to rewrite it. So 2, 1, 2, and 6, 3, 4 times the matrix B, which was a 2 by 2, 1, negative 1, and 2, 4. So we're going to get a 3 by 2 matrix. So let's do the product. And if I show all my math, what we're going to end up with is I'm going to do the first entry in the, so the 1, 1 entry times this one. So I'm going to have 2 times 1 plus, and then the second column, first row, times the first column, second row, plus 6 times negative 1. And that gives me just that entry. And so now for the entry of the second column, I'm going to do, see if I can erase these. For the second entry, I'm going to do the first row still, but now I'm going to do times the second column. So it's going to be 2 times 2. So this one is going to be 2 times 2 plus, and then 6 times the entry of the second row, second column. So plus 6 times 2. And so on. We move down the line. So for the second row, first column, I'm going to do the second row, first column here. So 1 times 1 and 3 times negative 1. And then for the second row, second column, I'm going to do second row A times the second column B. And I'm running out of colors here. So I'm going to stick with the blue there. So it's going to be 1 times 2 plus 3 times 4. And then for the third row, it's going to be the third row of A times the first column of B, third row of A times the second column of B. So I'm going to have 2 times 1 plus 4 times negative 1, and then 2 times 2 plus 4 times 4. And so that is the math that you do to get the product of the matrices. And you can kind of see that this, notice how here you have 1, negative 1, 1, negative 1, 1, negative 1. Here you have 2, 2, 2, 4, 2. Oh, that should have been 2, 2, 2, 4. Yeah. 2 times 2, this should be a 4. Because this should match up, right? So this one, how did we get it? It was 2 times 2 plus 6 times 4. I just wrote a 2 there, but notice that they stay the same. And what's changing is really as you move the row. All right, so now we're ready to finish this product. So 2 times 1, so that's 2 minus 6, which is negative 4. And 2 times 2, here is 4, plus 6 times 4 is 24, so 24 plus 4 is 28. And 1 minus 3, that's negative 2. 2 plus 12 is 14. 2 minus 4, so that's negative 2. And then 2 times 2 is 4. 4 times 4 is 16, so 4 plus 16 is 20. And so this will be the matrix A times B. So let's try what other product can we do? If I try, let's go back. If I try A times C, notice that A times C is not possible. So let me write that over here. So A times C is not possible because A is a 3 by 2 matrix, while C is a 3 by 3 matrix. So the columns and rows don't match. So we can't do it. But we can do C times A. So let's try C times A. C times A, and And the reason we can do that one is because the matrix C is a 3 by 3 matrix, and the matrix A is a 3 by 2 matrix. So the number of columns of the first one match up with the number of rows of the second one. So those are the same, so that means that we can do it, and the resulting product will be what dimension? So it will be a 3 by 2 matrix. So you are left with the rows of the first one and the columns of the second one. Gives you the new dimension. Okay, so let me write down C and A, and then we'll do that product again. Okay, so now that I've written the matrices, let's go through the product. So again, you do the row, first row times the first column. So I'm going to have 5 times 2 plus negative 1 times 1. Okay, so I'm doing 5 times 2, negative 1 times 1, and then 0 times 2. And then for the second entry, since we know we're going to have a 3 by 2, so I'm going to have 3 rows in just 2 columns. So my second column is going to be the first row times the second column. So 5 times 6, right? 5 times 6, negative 1 times 3, and 0 times 4. And now the second row is going to be second row times first column, second row times second column. So I'm going to have 1 times 2, 2 times 1, and negative 1 times 2. And the second column is going to be the first row again, but now times the second column. So 1 times 6 plus 2 times 3 plus negative 1 times 4. And the last row. So it'll be third row times first column, and then third row times second column. So I'm going to have 0 times 2 plus 1 times 1 plus 0 times 2. And the second column, third row, will be the third row times the second column. So 0 times 6 plus 1 times 3 plus 0 times 4. And this is the part that I was pointing out earlier, and that's how I also caught my mistake, that these notice that the numbers that are the second numbers, they all match up. So I have 2, 1, 2, 2, 1, 2, 2, 1, 2, because I'm multiplying that first column. It just, the rows are the ones that change and I stay in that first column. For the second column, notice that I have 6, 3, 4 is my second column, so I have those 6, 3, 4, 6, 3, 4, 6, 3, 4. And the numbers that are changing are as I move down the rows. And so this multiplication, once we do it all out, 5 times 2 is 10, minus 1, and that's 0. So 10 minus 1 is 9. And 5 times 6 is 30, minus 3 plus 0, so 27. And do this math over here. So 2 plus 2 minus 2, so it gives us 2. 6 plus 6 is 12, minus 4 is 8. And then those are zeros, that's nice. So I'll just get 1 and 3. And this will be our C times A matrix. So the main thing with multiplication is you got to make sure that you can do it. So that means that the number of rows, number of columns of the first one have to match the number of rows of the second one. And then your resulting product will be the rows of the first and the columns of the second. So the inside, the dimensions, tells you whether you can do it. The outsides of the dimensions tells you your resulting product. So again, the insides tell you whether it's possible, so those have to be the same. The outsides tell you the dimension of your resulting matrix. All right, I hope that that's helpful.